Today we're covering section 2.08 on graphing quadratics in standard form. Okay, and so let's walk through this, and you can see here first we have to go back. Quadratic function is written in this form here, where we have y equal to ax squared plus bx plus c, where a cannot equal 0. And the reason a can't equal 0 is if this is 0, then you no longer have a quadratic. The highest is going to be a 1 here, right, on the x. So that makes it a linear. So that's what that's saying. And when you write it in that form here, right, this is standard form. Okay, now, let's see here. So example 1, graph f of x is equal to x squared. Okay, so let's take a look here. F of x equal to x squared. We call this the parent function. And the reason we call this the parent function is because it's the most basic quadratic. So let's plug in some values. We're going to plug in values. Let's plug in -2, -1, 0, 1, and 2. And when I plug it into f of x squared, this one here, right, that's going to be f of -2, right, will be equal to, and it will be -2 squared, right? What's -2 squared? +4. So if I graph that, right, be over, 2, up, 4, it would be this point right here. If I put in -1, right, to find f of -1, that would be the quantity of -1 squared, which is +1. So left 1, up 1, there's that point. Okay, and I won't write out the work for the next 3. So 0 squared is 0, so I'll put that here. 1 squared is 1, so over 1, up 1. And then 2 squared is 4, so go right 2, up 4. And we can see that the basic graph is going to be something like this here. So the point that is down here, right, this point right here, this is called the vertex. And you can see that that vertex falls at 0, 0. You can also see it's a minimum. Remember from the last unit, relative to the y values, right, on it relative to the points around it. It's the lowest or the smallest y value. You can also see that it's an absolute minimum, right, because there is no point lower. Another part of the graph that's important for us to see is there is a line that it's symmetric about. We call this the axis of symmetry. So a lot of the lesson today, I'll abbreviate it as AOS, axis of symmetry. And you can see that for every point, there's a point on the opposite side that it's symmetric about. So say I pick this point right here. That is a distance here of 2, isn't it? And if I go 2 on the other side, right, so you can see there, that we have a matching point, right? Same distance away on the opposite side, right? We can pick this point here, right? That's a distance of 1. So if I go a distance of 1 on the other side, and it doesn't matter, it doesn't have to be a nice point. I could pick this point right here, 1, 2, 3. And if I go the same distance on the other side, I have a matching point. The equation of this axis of symmetry in this problem is x equal to 0, right? X equals tells me it's a vertical line. 0 because it's going through 0 on the x-axis. What's the y-intercept for this problem? Where's across the y-axis? At 0, right? Right there, right? What's the x-intercept? Yeah, and where does it cross on the x-axis? Well, it crosses on the x-axis here at 0. Notice too, another important thing is that this opens up. Okay, are we good with that? So the next thing we're going to do is we're going to come over here and we're going to do the steps right here to graphing in standard form, right? A quadratic in standard form. So I'm going to come back over here. So the first step is to identify the y-intercept. Now the y-intercept is really nice because it is, hang on here, I got to get the right color. It's just the value of c. Now when I say c, right, if we go back up here, right, that's the constant in the equation. Okay, that'll be the y-intercept. So c is the y-intercept, right? I'll just write here that it's the constant. Notice in example 1, what was the constant? Right, if I'm back up here in example 1, what's the constant? Do you see a constant? I don't see a constant, right? It's missing, so what is the value of c? Right? So that would be the y-intercept. Okay, can we keep moving? So step 1 is identify the y-intercept. Step 2 is decide the direction the parabola opens. Ah, this is good. If a, now remember a, okay, a is the coefficient of the x squared, okay? So if the coefficient of x squared is greater than 0, that means that it's positive, right? Which direction is it going to open? Well, positive things, you can think of it this way. It's going to open up. You could think positive things make you smile, right? And so another thing that we'll know is that our vertex, right, will be a minimum. Now, if that leading a, right, the coefficient on the x squared is negative, it's going to cause the parabola to turn down. You can think negative things make you frown. So then you can see in this case, when it turns down, right, the vertex will be a maximum. Number 3, let's compare it with the standard graph. And when I say standard graph, right here, the standard graph, I said see example 1 because example 1 is the standard graph, right? So if the absolute value of A, now remember, we already know that the sign of A, whether it's positive or negative, tells me if the parabola is going to turn up or if it will turn down, okay? Now the number that's in front of A, if you just strip away the positive or negative, that's going to tell me how wide or how narrow it's going to open, okay? So if the absolute value of A is equal to 1, right, that's the middle one here I'm looking at. If it's equal to 1, then it's going to be the same, right, as the parent graph. I'll just say as parent function. F, and there we go. If the absolute value of A is less than 1, it's going to be wider than the parent function. And if the absolute value of A is greater than 1, it's going to be narrower. Okay, so that's good to know. 4, find the axis of symmetry. That's going to be really, really nice. The axis of symmetry is the opposite of B over 2A. Remember, A and B are in that standard equation, right? All the way back at the top, right? A is in front of the x squared, B is in front of the x. So we will fill in this formula. This is an important one for you to memorize. Now, for 5, it says find the vertex. Now, this is important because it says which lies on the axis of symmetry. If it lies on the axis of symmetry, then we know the x-coordinate because we just found the x-coordinate. Okay, it's the value of the axis of symmetry. So here, let's just do. Oops. So here, right, is the opposite of B over 2A. That's the x-coordinate. The y-coordinate, what you're going to do is you're going to substitute the x-coordinate, right, the x-coordinate, into the quadratic equation and solve for y. So we'll go through all these examples. Six is make a table, place the vertex in the middle of the table and pick x values around the vertex coordinate, solving for the corresponding y values, right, graph. And then 7 is find the x-intercepts. I'll actually probably flip-flop these last two. I think that would be easier. Okay, can we go down to the examples? So example 2 on the back. y is equal to 2x squared minus 8x plus b. So the first thing I'm going to ask, is this in standard form? Remember, standard form is y is equal to ax squared plus bx plus c. So is it in standard form? Yeah. What's a? 2. What is b? What's b? Negative 8. Good job. And what is c? 6. Right? Okay. Now, if you remember correctly, first we're going to identify the y-intercept. You guys remember how to find the y-intercept? It's going to be c, right? What's c? It's the 6 that's right here. Oh, yeah, that's nice. So on the y-axis at 6, so I'm going to go up here, 1, 2, 3, 4, 5, 6. That's right here. Plotting my point. I'll label that with a 6. So I'm doing good there. Step 1, find the y-intercept. 2 is to decide the direction the parabola opens. Okay, decide which way the parabola opens. So what is a? A is 2. Okay, so is a positive or negative? So since a is positive, is greater than 0, we know it's going to turn up or turn down. Positive things make you smile, right? So we know it's going to turn up, and we know therefore that the vertex will be a minimum. We can also just think about how it compares with the standard graph, step 3. So we just need the absolute value of a. So the absolute value of a will be the absolute value of 2, which is 2. So we're going to compare that with 1. Okay, so I'm going to put a box here that needs to be filled in. Is it less than 1, equal to 1, or greater than 1? Yeah, that's definitely greater than 1. So if it's greater than 1, if we look back at our notes, right, greater than 1 tells me that it's going to be narrower than the parent graph. So I'm going to come down here, and I'll say the graph is narrower than the parent graph. This graph is narrower than the parent graph. So that's good. So I know it's going to be a narrow graph. I know it's going to be turning up. I know the y-intercept is 6. So the next thing is to find the axis of symmetry. Okay, axis of symmetry. So I'll do that right here, the AOS. And we know that the formula is x is equal to negative b over 2a. So we've got to fill in what we know. There we go. So we know here that x is going to be equal to the negative of b. What's b? Oh, so it's the negative of negative 8 over 2 times what's a? 2. So that's going to be positive 8 over 4, which is 2. So x equal to 2 is my axis of symmetry. So, okay, fine. 2. Okay, this is 2 right there, and my axis of symmetry will look something like this. Are we okay there? Now we know the vertex falls on the axis of symmetry. Okay, so I'm going to find the vertex now. Just do it right here below. So the x coordinate of the vertex, what's it going to be? Isn't it going to be the axis of symmetry value? So how do you find the y coordinate? Well, to find the y coordinate, you're going to take the equation, which is y is equal to 2x squared minus 8x plus 6, and we're going to stick the 2 in. And so it's going to be y is equal to 2 times 2 squared minus 8 times 2 plus 6. What is 2 squared? What's 2 squared, you guys? 4. And then 4 times 2? 8. So I'm going to write 8 here. Minus, and then 8 times 2 is 16 plus 6. 8 minus 16 is negative 8. Negative 8 plus 6 is negative 2. So my vertex is going to be at 2, negative 2, right? Where this comes from here, and this one is right here. So I can go over to down negative 2, and so I know that goes here. There's my vertex. So I actually have a pretty good shape, right? A couple of things that I do know right now. I know that the vertex, I know that I have one point here at 6. So, and I know that this is a distance away here too. So if I go 2 on this side, I have another one, don't I? I actually have a pretty good shape. The reality is that's probably pretty good. But let's go ahead. Let's find the x-intercepts now, because we can. To find the x-intercepts, you're going to set y equal to 0. So, okay. So I'm going to take my equation, 2x squared minus 8x plus 6, set that equal to 0, right? Or y equals, okay, the equation, I can say 0 equals that. I see that I could take a 2 out. They all are divisible by 2, so I'm left with x squared minus 8, not 8x, minus 4x plus 3. Oh, doesn't this factor nicely, you guys? X minus 3x minus 1, right? Factors of 3 that had to be negative 4. Is that correct? That's equal to 0. So notice here, we either have x minus 3 equal to 0, so x is 3. And then here you have x minus 1 equal to 0, so x is 1. So on the x-axis, you can see it crosses at 1 and 3. Now, I think that you guys can see we really don't need to find extra points for this. But that would be the next step, and so I would make a table x, y. And you always put the vertex in the middle of the table. I'll put it here, vertex. And our vertex was 2, negative 2. And then we just count up from 2, so 3 and 4. Count down from 2, that's 1 and 0. If 0 is the x-coordinate, isn't that going to be the y-intercept? And don't we already know that it's going to be 6? Now here's the cool thing, right? Right. This is 2 away here to go from 0 to 2. Do you agree? Notice that go from 2 to 4, that's also 2. So because those are the same distance, it turns out that these will be the same value. So this has to be a 6 also there, which I already have that. Okay, and then if we put in 1 into the equation and solve it, we know we're going to get 0 out because it's an x-intercept. So, and then we know that going from 2 to 1 is the same distance as going from 2 to 3. So we know that their y values will also be the same. So this will be 0. Normally you have to plug it in, okay, to figure that out. But in this case, we found all the values by just finding the x and y intercepts. How are we doing? Are we okay? What's the matter? It is a lot to do. Okay. So, can I move this down? So let's do the next one, okay? So again, is this one in standard form? Y equals negative x squared plus 2x plus 3? Standard form? Yeah, that's standard form. So what is A? Negative 1, right? What's B? And then what is C? Three. So 3 is the y-intercept, by the way. That's one of the first things we find. It's the easiest. So I know it's going to cross at 3 here. What's A? Well, what's the value of A? It is the direction that it's going to open, so that's good. Value of A is negative 1. So because it's negative, what do we know? We know A is less than 0, right? What does that tell me? Okay, well, yeah, it's negative. So what does that tell me? Is it going to turn up or turn down? Because negative things make you frown, right? So the vertex will be the max for max. Okay, and let's look at the absolute value of A now. Oh, let's not do this hence. So let's see here. So absolute value of A is what we're looking for now. This is going to be the absolute value of negative 1, which is 1. What does that tell me about the graph? Oh, you have to compare it with 1, right? Oh, that's what I did up here. So let's do this here. So now you're going to take that 1 and you always compare it with 1. So is it less than 1, equal to 1, or greater than 1? Yeah, it's equal to 1. So therefore, we know that it has the same shape as the parent graph, right? So the graph, same as parent graph, same as parent. Okay, so AOS, right? What's AOS stand for? Axis of symmetry, right? The formula is x equal to negative b over 2a. So in this case, x will be equal to negative of b, which is 2, divided by 2 times a, which is negative 1. So it's negative 2 over negative 2, which is 1. X equal to 1. Now that I have the axis of symmetry, and we have the y-intercept, right? We know this is a distance of 1 here. If I go a distance of 1 on the other side, I have another point. We can do that right away. So that's super good. I can find the vertex now. The x-coordinate. What's the x-coordinate of the vertex going to be? 1, because it's the same as the axis of symmetry, right? So we just have to plug that into the original equation to find the y-coordinate. So the original equation is y is equal to negative x squared plus 2x plus 3. So it's going to be y is equal to the negative of 1 squared plus 2 times 1 plus 3. Now be really careful on this one. A lot of people try and square the negative, but the negative is actually not. You have to do the square first, then apply the negative. So this is negative 1 plus 2 plus 3. So negative 1 plus 2 is 1, plus 3 is 4. So my coordinate is going to be 1, 4, right? The 4 coming from here, and the 1 coming from way up here. Okay, how are we doing? Good. Let's find our x-intercepts now. So I'm going to take that negative x squared plus 2x plus 3, set this equal to 0. And you see how we have the leading negative here? That always creates problems. So we're going to take out the negative, right? I'll take it out as a negative 1, and it leaves me with, divide each of those by negative, it's just going to change their sign. So x squared minus 2x minus 3 equal to 0. So that actually factors really nicely, doesn't it? So it's negative 1 times x, and here x equal to 0. And factors of negative 3 that had to be negative 2, aren't they negative 3 and positive 1? So either negative 1 has to equal 0, which it never will, or x minus 3 has to equal 0, so x is 3, or x plus 1 has to equal 0, so x is negative 1. So I can plot a point at negative 1, and 1, 2, 3. That's actually really good. Extra points. So here's my x and my y. Oh. Let's put the vertex in the middle. 1, 4. This is my vertex. counting up, right? 2, 3, 4. I'll do extra point this time. Counting down 0, -1, -2. So what I know is that these here will be the same. I know these here will be the same. And I know that these here will be the same. We already know that 0 will be matched with the 3 because it's a y-intercept. Which puts the 3 here also. We already know that -1 will be paired with 0. So that means this is 0 also because these are x-intercepts. So, and then if I put in -2 or 4, let's do 4. So if x is equal to 4, I would just plug it into the equation, right? So y equal to -x squared plus 2x plus 3. So it's going to be y equal to the negative of 4 squared plus 2 times 4 plus 3. So 4 squared is 16, and then you apply the negative, so it'll be -16 plus 2 times 4 is 8 plus 3. So -16 and 8 is -8 plus 3, that's -5. So I know I get -5 in this location, but it also matches up with the -2. And you can see that's way off my graph, and so I could just draw my best curve through this. I don't remember drawing my curve in the previous one, did I? You guys let me get away with not doing that? Okay, so did you see that I forgot to actually draw my best curve through example 2? So if I were to come up here, right, it's going to look something like this. Okay, any questions? Let's move on to that last page then. Here's the thing. There's actually 2 other forms. I don't want to go really heavy into the 2 other forms, but you guys should know them, okay? Because they're great forms. So we have one here. This is example 4a. This is intercept form. And this one is vertex form. So, and I'll just share with you what's really nice about for intercept form, right? It's because of the x-intercepts are easy to identify. You literally can just set x plus 4 equal to 0 and get x equal to -4. And then you can do the same thing here, x minus 9 equal to 0. So x is equal to 9. Get the idea? Okay, and so you have that really nice. But the reality is if it's given to you in this form on the test, you can always put it in standard form. So just to review that, right, what I would do is I would leave the negative here. Let's write it one time. Let's see here. So, and then I can multiply it together and put it in standard form. So distributing it all out. So I'll have y is equal to the negative of, so I'll take the x here first, distribute that through. So x times x is x squared. And then x times minus 9 is minus 9x. Then I'm going to distribute that plus 4 through. Plus 4 times x is plus 4x. Plus 4 times minus 9 is minus 36. So I do have a couple of like terms here that need to be combined. So negative 9x plus 4x is minus 5x minus 36. So, and then I need to distribute the negative through. So it gives me y is equal to negative x squared plus 5x plus 36. And can I now follow the steps that we just have written down? Right? But do know, if you recognize that it's in that form where you see the two factors put together, that it's intercept form, you can identify the x-intercepts nice and easy. Clear? Okay, so, and then the last one is this vertex form. And the reason why the vertex form is really nice, let me write it over here. Y equal to 3 times x minus 1 squared plus 8. And it's always a quantity squared and then plus or minus a number. It could have a number in front. But here's the thing. If it's in vertex form, if you take the opposite of this number, that's a positive 1, and you take the same, just take this number, right, the same as this number, which is the plus 8, this is your vertex, right? And because you know that the axis of symmetry is related to the x coordinate, it'll be x equal to positive 1. So you can identify the vertex and the axis of symmetry really quickly. Do you see that? Okay, and again, don't expect you to know that. So, but on this one, what I would do is I would put it into standard form. So in standard form, what we're going to do is I will have here y is equal to 3 times a large quantity plus 8. I'm going to distribute this out a little bit. Remember, square to the left, square to the right, double the product and fight. Because we have a quantity squared here, so I'm going to expand that. So I'm going to take the x, square to the left gives me x squared. And then I have the square to the right. I'm going to take that minus 1 and square it. It becomes plus 1. Are we together? Then you have to double the product. Well, the product is going to be x times negative 1 or negative 1x. There's your product. Doubling that gives you minus 2x. And then distribute the 3 through, so that becomes 3x squared. 3 times minus 2x is minus 6x. And then 3 times 1 is plus 3. And then add the 8. And so y equals 3x squared minus 6x plus 11. Okay, and now that is in standard form, and if you're asked to graph it, you can use that information to do it. Okay, are we clear? Yeah? Okay. That will wrap up our lesson.